The rhythmic metallic thud of a massive copper knife switch slamming home resonates through a damp basement in Bond Street. It is 1885. A shower of violet sparks illuminates the sweat on a young man's brow, followed by a low-frequency hum that vibrates the very marrow of his bones. This is the sound of the future being forced into existence, a sound that the residents of Victorian London, accustomed to the hiss of gas and the clip-clop of hooves, are not yet prepared to hear. Today, if you walk along the Thames Path at Deptford, near the luxury developments of Convoy's Wharf, you will find a strange, eerie silence where the world's first cathedral of power once stood. There are no towering chimneys belching smoke, no rhythmic pulse of colossal reciprocating engines. The gargantuan brick structures that Sebastian Ziani de Ferranti built have been erased, replaced by the sterile glass of modern apartment blocks and the quiet lapping of the river against rotting timber pilings. The very ground, once saturated with the ozone of 10,000 volts, is now just high-priced real estate. It is the ultimate irony of British industrial history. The man who essentially invented the modern world's electrical grid is a footnote, his greatest monument demolished, while the names of his rivals, Edison and Tesla, are etched into the global consciousness. We live in Ferranti's world, powered by his principles, yet we have forgotten the audacity of the 24-year-old boy wonder who decided to electrify London from a muddy marshland 5 miles away. The architect of the invisible. To understand the scale of the forgotten, we must first dismantle the Victorian cliché. We imagine an era of Sherlock Holmes, hansom cabs, and flickering gaslight. But by the mid-1880s, London was a battlefield for an invisible force. The city was a chaotic patchwork of tiny lighting stations, each serving a single block or a single building, often at voltages so low the copper wires had to be as thick as a man's arm. Sebastian Ziani de Ferranti, a young man of Italian-British descent with a mind like a precision-engineered turbine, looked at this mess and saw a fundamental flaw. He realized that the future didn't lie in small, local generators, but in massive, centralized power plants located far from the city center, where coal was cheap and water for cooling was abundant. In 1882, at the age of just 18, Ferranti had already patented his Ferranti alternator, a machine capable of generating alternating current, AC, with unprecedented efficiency. While Thomas Edison was doubling down on direct current, DC, in New York, a system that could only transmit power about a mile before the voltage dropped, Ferranti was dreaming of a high-pressure system that could span counties. He was the first to realize that electricity should be treated like high-pressure water, pump it at high voltage to minimize loss, then throttle it down with transformers at the point of use. The Grosvenor Gallery experiment. The story truly begins in the shadows of the Grosvenor Gallery on Bond Street. This was the epicenter of the aesthetic movement, a place for Oscar Wilde and the artistic elite. But in the basement, Ferranti was performing an industrial exorcism. The gallery had installed a small, failing electrical plant that was annoying the neighbors with its vibration and smoke. Ferranti was brought in as a consultant and, within months, had completely redesigned the system. By 1886, he had transformed the Grosvenor Gallery into the most powerful AC station in the world, running at 2,400 volts. This was unheard of. It was considered suicide. The prevailing wisdom of the Board of Trade was that anything over 200 volts was a death sentence waiting to happen. Ferranti ignored them. He draped his cables over the rooftops of London, literally stringing the fire of the gods above the heads of unsuspecting shoppers and aristocrats. He used rubber-insulated cables suspended from steel wires, a precarious web that powered 30,000 lamps from Mayfair to the city. The aesthetic of this era was one of brutalist elegance. Imagine the engine room, polished mahogany control panels, brass gauges with trembling needles, and the smell of hot oil and ionizing air. The men working here weren't electricians in the modern sense. They were pioneers handling a force they barely understood, using tools that looked like instruments of torture. Ferranti himself was often found in the thick of it, his waistcoat stained with grease, adjusting the brushes on a dynamo that could have vaporized him in a heartbeat. The paradox of the boy wonder. The great paradox of Ferranti's life was his age versus his responsibility. At 24, he was appointed chief engineer of the London Electric Supply Corporation, LESCO. He was given a mandate that sounds like science fiction even today. Build a power station at Deptford that would supply the entirety of London. This was to be the eighth wonder of the world. The establishment viewed him with a mix of awe and terror. To the aging lords of the gas companies, he was a dangerous radical. To the investors, he was a genius who could turn coal into gold. But to the history books, he became the man who arrived too early. He was building the 20th century in the heart of the 19th, and the friction between his vision and the technology of his time would eventually create a spark that nearly consumed him. The Deptford site was chosen not for convenience, but for strategic necessity. It sat on the Thames, allowing colliers to unload coal directly into the boilers. It was the birth of the superstation concept, a blueprint that every power plant from Battersea to Chernobyl would eventually follow. But in 1887, as the first bricks were laid in the Deptford mud, the world thought Ferranti was building a tomb for his own reputation. The 10,000-volt gamble. To appreciate the sheer mechanical audacity of Sebastian Ziani de Ferranti, one must understand that in 1887, the electrical industry was operating in a state of primitive caution. The safe limit for transmission was considered to be 2,000 volts. Ferranti's plan for Deptford required 10,000 volts. To his contemporaries, this wasn't just engineering, it was a flirtation with atmospheric lightning. There were no textbooks for this. There were no off-the-shelf components. Every switch, every insulator, and every foot of cable had to be imagined, tested, and manufactured from scratch in Ferranti's own workshops at Charterhouse Square. The central problem was the conveyance. How do you move 10,000 volts through a crowded city without turning the streets into a giant electric chair? Standard rubber and gutta-percha insulation simply disintegrated under the stress of such high electrical pressure. Ferranti's solution was a stroke of counterintuitive genius: paper. He realized that brown paper, if dried and impregnated with a specific mineral oil, ozokerite, possessed a dielectric strength far superior to expensive rubber. The anatomy of the Ferranti main. The Ferranti main cable was a masterpiece of Victorian mechanical engineering. It wasn't a wire, it was a rigid 20-foot pipe. It consisted of two concentric copper tubes. The inner tube carried the current, wrapped in 20 layers of oil-soaked brown paper. This was then inserted into a larger copper tube, which served as the return and was kept at earth potential. The whole assembly was encased in a protective iron pipe, with the gaps filled with more hot pitch. Construction was a logistical nightmare. Ferranti needed 28 miles of this rigid piping to reach the heart of London. Because the sections were rigid, every joint was a potential point of catastrophic failure. He designed a friction-tight joint that could be driven home with a sledgehammer, a process that required absolute precision. The cost was staggering. LESCO spent over £100,000, roughly £12 million today, just on the transmission lines. Critics, led by the formidable Sir William Preece of the Post Office, mocked the boy wonder, predicting the cables would act as a giant capacitor and blow the generators to pieces. They weren't entirely wrong. Ferranti was about to discover what we now call the Ferranti effect, where the voltage at the end of an unloaded line actually rises higher than at the source, a phenomenon that nearly derailed the entire project. The Cathedral of Steam. While the cables were being laid, the Deptford station itself was rising like an industrial cathedral. The scale was unprecedented. Ferranti planned for two 1,500 horsepower engines as a starting point, but his ultimate vision involved four gargantuan 10,000 horsepower units. To put that in perspective, the largest engines in existence at the time were barely 1,000 horsepower. The engine hall was a cavernous space of brick and iron, dominated by Hicks Hargreaves coreless engines. The flywheels alone were 45 feet in diameter and weighed hundreds of tons. These weren't just machines, they were massive kinetic batteries. When they spun up to their operational speed, the ground for half a mile around Deptford would thrum with a subsonic vibration. Ferranti's alternators, which he designed himself, were direct-driven, a radical departure from the belt-driven systems of the day. He used huge armature rings built of copper strips, held in place by massive bolts that looked like they belonged on a battleship. The Merindon Inquiry, the War of Standards. By 1889, the British government could no longer ignore the Ferranti menace. The Board of Trade launched the Merindon Inquiry to decide whether AC or DC should power the capital. This was the British equivalent of the War of Currents. On one side stood the DC advocates like R.E.B. Crompton, who argued that high voltage was inherently murderous and that a distributed system of small local stations was the only safe path. Ferranti stood before the inquiry, a 24-year-old with the poise of a veteran, arguing that the efficiency of high-voltage AC was the only way to make electricity affordable for the masses. He wasn't just fighting for a technical standard, he was fighting for the democratization of power. He famously testified that the 10,000-volt system was actually safer because it was concentrated in a few heavily guarded sites rather than thousands of small, poorly maintained street-level basements. The Chisel Test, a cinematic defiance. The turning point for public perception came during a demonstration that has since become a legend in the history of engineering. To prove the safety of his concentric cables, Ferranti's assistant, Harold Kola, stood in front of a gathered crowd of skeptical officials and journalists. He held a sharpened steel chisel against a live 10,000-volt cable. With a deep breath, another assistant swung a heavy sledgehammer, driving the chisel straight through the iron casing, the copper, and the paper insulation. If Ferranti's safety theories were wrong, Kola would have been vaporized instantly. Instead, as the chisel hit the inner conductor, it created a dead short to the earthed outer casing. The safety fuses at the station blew instantly, the lights dimmed, and Kola stepped away, perfectly unharmed. It was a moment of pure industrial theater, a cinematic gamble that silenced the critics and proved that 10,000 volts could be tamed. The engineering sacrifice. But the struggle wasn't just technical, it was financial. The London Electric Supply Corporation was hemorrhaging money. The sheer ambition of Deptford, building for a future demand that didn't yet exist, meant that investors were getting nervous. The project was constantly plagued by small but expensive failures. In 1890, a fire at the original Grosvenor Gallery station, caused by a spark jumping across a high-tension switchboard, cut off power to thousands and shattered public confidence. Ferranti, ever the perfectionist, was often at odds with his board of directors, who wanted profits now, not a technological utopia 20 years in the future. He was working 18-hour days, often sleeping on a cot in the engine room, surrounded by the smell of hot grease and the relentless, driving pulse of his creations. The moment of triumph arrived not with a fanfare, but with a terrifying, low-frequency thrum that shook the window panes of Deptford's surrounding slums. In February 1891, Sebastian Ziani de Ferranti stood in the control room of the world's first true superstation. He signaled his engineers. The massive steam valves were opened, the coreless engines began their slow, rhythmic heave, and for the first time in human history, 10,000 volts of alternating current began to flow through the Ferranti mains. It was a technological Everest. At that moment, Ferranti was not just an engineer, he was the master of a new elemental force. The light of London was no longer a dream. For a brief, shining window, Ferranti was the toast of the Victorian scientific elite. Lord Crawford, the chairman of LESCO and a man of immense wealth and astronomical interests, championed him as the Napoleon of electricity. The newspapers were filled with breathless accounts of the Colossus of Deptford. To the public, it seemed like magic. Power generated in a muddy riverside marsh was lighting the chandeliers of the Savoy Hotel and the galleries of Bond Street miles away. The efficiency was undeniable. Where Edison's DC plants were losing nearly 30% of their power to resistance over a single mile, Ferranti was seeing losses of less than 2% over 7 miles. The midnight spectacle. The social peak of this era was surreal. Ferranti's workshops became a mandatory stop for the era's luminaries. Picture the scene: the Prince of Wales, later King Edward VII, visiting the station, leaning over the brass railings of the gallery, his face illuminated by the eerie, violet glow of the open-air switches. Ferranti would demonstrate the power by drawing massive arcs of artificial lightning, the snap of the discharge sounding like a pistol shot in the echoing hall. It was the ultimate Victorian spectacle, the raw power of nature tamed by the intellect of a man who hadn't yet reached his 30th birthday. But behind the scenes, the cracks were widening. The cost of this ambition was astronomical. By 1891, the London Electric Supply Corporation had spent over £800,000, a sum equivalent to nearly £100 million today. The investors, who had initially been seduced by the boy wonder's vision, were beginning to experience the cold feet of the financier. They didn't want a cathedral of power. They wanted dividends. The beginning of the end was heralded by a smell, the acrid, choking scent of burning rubber and oil-soaked paper. On November 15, 1890, a major fire broke out at the Grosvenor Gallery substation. A high-tension switchboard, pushed beyond its limits, had arced. The resulting blaze didn't just destroy the equipment, it severed the connection between Deptford and the heart of London. The city went dark. For the critics, this was the "I told you so" moment they had been waiting for. The Board of Trade, always cautious, began to tighten the noose of regulation. Then came the Ferranti effect. It was a technical ghost that haunted the lines. Engineers discovered that when the load was light, the voltage at the London end of the cable actually rose above the 10,000 volts being pushed from Deptford. It was a phenomenon of capacitance that Ferranti hadn't fully predicted. While he eventually solved it with clever transformer adjustments, the psychological damage was done. To the investors, the system felt unstable. The boardroom coup. The final blow wasn't a mechanical failure, but a human one. In 1891, the Lesko board, panicked by the mounting debts and the technical setbacks, did the unthinkable. They stripped Ferranti of his authority. They viewed his perfectionism as a liability. They wanted to scale back, to play it safe, to stop the reckless expansion. Ferranti, a man of uncompromising integrity and immense ego, refused to be a mere figurehead. At the age of 27, the man who had designed every nut, bolt, and cable of the world's most advanced power system walked out of the Deptford station for the last time. The irony is staggering. The board replaced his vision with a safe approach that ultimately proved less efficient and more costly in the long run. They cut the 10,000-volt transmission back to 2,500 volts, effectively crippling the very advantage the superstation was built for. Ferranti's departure marked the end of the heroic age of British electrical engineering and the beginning of the corporate age, where vision was subordinated to the quarterly balance sheet. A modern echo, the disruptor's curse. There is a profound parallel here to the modern tech world. Ferranti was the original disruptor. He followed the "move fast and break things" mantra a century before Silicon Valley coined it. Like many visionary founders today, from Steve Jobs in his early years to the pioneers of nuclear fusion, Ferranti was an engineer who understood the future so clearly that he became frustrated by the present's inability to keep up. He was punished for being right too early. Today, we see the same pattern in green energy and grid-scale storage. The visionary creates the breakthrough, the market panics at the initial cost, the vision is diluted, and 20 years later, the world realizes the visionary was right all along. As Ferranti boarded the train away from Deptford, he left behind a monument that would continue to power London for another 60 years, but it would no longer bear his name as the man in charge. He was a creator who had been evicted from his own creation. The silence that followed Ferranti's departure from Deptford in 1891 was not the silence of failure, but the quiet, simmering heat of a man reinventing himself. While the London Electric Supply Corporation struggled to maintain his vision, Sebastian Ziani de Ferranti retreated north to Hollandwood, near Manchester. He didn't just build a factory, he built an empire of the small. If Deptford was his attempt to command the lightning of the gods, his new venture, Ferranti Limited, was an attempt to measure it. He realized that for electricity to become a true industry, it had to be quantified. He perfected the Ferranti-Thomson meter, the little box with a spinning disc that would eventually find its way into every basement and hallway in the British Empire. This is the bitter irony of his legacy. The man who dreamed of 45-foot flywheels and 10,000-volt cathedrals is most remembered by a generation of engineers for the humble clicking device that tracked a household's monthly bill. The Hollandwood pivot and the dawn of electronics. In the red brick canyons of Hollandwood, Ferranti's mind never slowed. He transitioned from the raw power of steam and copper to the delicate intricacies of electronics. By the early 20th century, Ferranti Limited was a name synonymous with precision. They produced everything from domestic heaters and radios to the massive transformers that would eventually form the backbone of the British national grid in 1926, a grid that was, in essence, just a larger version of what Ferranti had tried to build in Deptford 40 years earlier. The technical depth of his later work is staggering. He was obsessed with the efficiency of steam turbines, working closely with Charles Parsons to refine the machines that would eventually make his own giant reciprocating engines at Deptford look like museum pieces. He was a pioneer of the all-electric house, imagining a world where labor was eliminated by the flip of a switch. But as the 20th century ground on, the man himself began to fade behind the corporate logo. He became a grand old man of the institution, a recipient of the Faraday Medal, while the radical, sledgehammer-swinging visionary of 1889 was scrubbed clean by the respectability of the Edwardian era. The Ghost of Deptford, a century of power. Back on the banks of the Thames, Deptford Power Station lived a long, shadowed life. The A Station, Ferranti's original masterpiece, was joined by the B Station in 1948. For decades, these two giants provided the heartbeat of London, surviving the Blitz and the transition from private power to nationalization. The site became a maze of soot-stained brick and pulsing turbines, a place where generations of men worked in a constant 100-decibel roar. But the end came in 1983. The logic of the superstation that Ferranti had invented had progressed so far that Deptford was now too small, too central, and too dirty. The fires were extinguished. The great chimneys, which had stood as navigational markers for Thames mariners for nearly a century, were brought down in a cloud of dust. The machinery, the massive Ferranti-designed alternators and the Hicks-Hargreaves engines, was largely sold for scrap, melted down to build the very world they had once powered. The modern disappearance. Stowage, London SE8. If you travel to the end of Stowage in Deptford today, you are met with a wall of silence. There is no museum. There is no towering statue of the boy wonder. The site of the world's first high-voltage power station is now a construction site for luxury apartments known as Convoy's Wharf. The only physical remnant is a stretch of river wall and a few rusted bollards where the coal colliers once moored. The Ferranti mains, those revolutionary paper-insulated pipes that once carried the fire of the 19th century under the streets of London, still lie buried in the mud of the Thames, forgotten and severed, their 10,000-volt pulse long since vanished. The company that bore his name, Ferranti Limited, met a similarly tragic end. After decades of being at the cutting edge of computing, producing the Ferranti Mark I, the world's first commercially available electronic digital computer, the company collapsed in 1993 following a massive financial fraud involving an American subsidiary, International Signal and Control. A century of British industrial heritage was liquidated in a matter of months. The name Ferranti moved from being a symbol of the future to a legal footnote in a corporate scandal. The Mirror of Creation. Why does the story of Sebastian Ziani de Ferranti matter? It matters because it reveals the predatory nature of progress. We like to think of history as a steady climb, but it is actually a series of cannibalizations. The world took Ferranti's AC grid, his high-voltage transformers, his meters, and his superstation concept, and once it had digested them, it discarded the man. He represents the overlooked figure who was too right too soon. He was a man who looked at a gaslit world and saw a planet pulsing with invisible energy, yet he ended his days watching the world adopt his ideas while forgetting his struggle. To walk the empty, silent streets of Deptford today is to realize that the modern world is built upon the ruins of geniuses who were silenced by boards of directors and erased by the very efficiency they created. We flick a switch and expect light, never realizing that the bridge between the Dark Ages and the modern world was paved with the paper-insulated dreams of a 24-year-old who dared to play with lightning. He gave us the fire of the gods, and we rewarded him with a bill for the meter.